protocol stacks. Computers transmit messages to each other by using protocol stacks. Protocol, rules dictating how to do something. Protocol stack, set of protocols working together to accomplish a goal. Network protocol, rules about sending, receiving, and packaging data. Operating systems typically implements protocol stacks, manages interaction between a device's hardware and its software. Linux, Windows, and Mac OS are all operating systems. TCP/IP is the protocol stack used by the Internet. It has 4 layers: application, transport, Internet protocol, and network.
So the first layer is going to be the application layer. This is the layer that is closest to the user, and it's going to be for application-specific protocols. Say you're on the computer, you're going to send your friend an email, you're on the email application, say Outlook, you press send. This is the application layer that's going to touch that email first. It collects and formats application data. Examples of application layer protocols are file transfer protocol, HTTP that's used over the World Wide Web, SSH is for secure remote access. Next we have the transport layer, which is where TCP, Transport Control Protocol, lives. When sending data, it creates and sequences network packets, and when receiving the data, it reconstructs the network packets into the data. It's in charge of quality assurance. It wants to make sure that the data gets received in the appropriate condition. It packages some error checking in with the network packets and also adds a port number. The port number is a way to identify a specific process that's going to be associated with that data, so when it's received, the recipient will know what to do with it, where to send it. What application layer protocol is going to be in charge of processing it? Next, we have the Internet Protocol layer, which connects devices using an IP address. The IP address is going to identify the network as well as the host. And this layer is responsible for addressing and routing network packets. Lastly, we have the network layer, also sometimes called the hardware layer or the link layer, and it converts the binary packet data into network signals to be sent over physical hardware, such as an Ethernet network card, a modem, a phone line. And here we have a little flowchart that shows computer A is sending data and then computer B is receiving the data. And as you can see, the data is going to start at the application level on computer A, where the user is going to be in front of that application level, probably send, let's say, an email, right? Press send on that email. The first protocol layer in charge of that data is going to be the email application's protocol layer. Then it's going to go down to the transport layer, the IP layer, the network layer, and the network layer on computer A is going to send it across the internet to the network layer on computer B, and then it's going to go back up the hierarchy from the network layer to the IP layer to the transport layer, and finally to computer B's application layer. Computer B's user right in front of the application layer is going to be able to access that data and read the email.